ratio tests. We are going to solve this, and we determine whether the following series converges or diverges using a ratio test. So remember that you have to remember all these three properties. These are series in form of an. These are series in form of an. If a limit as n approaches infinity, an plus 1 divided by an is L, if your L is less than 1, automatically the series converges. And 2, if this is 1, limit as n approaches infinity, an plus 1 divided an is L is greater than 1, this diverges. 3, limit as n approaches infinity, an plus 1 divided by 1 is L, is now your L is infinity, this diverges also. And 4, limit as n approaches infinity, an plus 1 divided an is 1, the series is inconclusive, it is inappropriate. So we will solve the following examples and determine whether the series. Example 1, the series is given by a summation as n lands from 1 up to infinity, n factorial divided by 10 raised to the power n. Now we determine whether this series converges or diverges using a ratio test. Remember that ratio test states that limit as n approaches infinity, an plus 1 divided an is equals to n. So, and your an is equals to n factorial divided by 10 is the power n. N factorial divided by 10 is the power n. So an plus 1 will be, you add 1 where you have n plus 1 factorial divided by 10 is the power 1. This is equivalent to 2. A factorial, n plus 1, n factorial divided by 10 is the power 1. So, and an plus 1 divided an is given by 10 is the power n, 10 is the power n, and so an plus 1 is this, divided by an. Are we together? So n plus 1, n factorial, 10 is the power n times 10 multiplied by reciprocal of this, 10 is the power n, 10 is the power n, all over n factorial. So limit as n approaches infinity given by n plus 1, n factorial times 10 is the power n, all over 10 is the power n times 10 n factorial. So n factorial and n factorial cancel. Again, 10 and 10 is the power n cancel. Your limit simplifies to limit as n approaches infinity, n plus 1 divided by 10, n plus 1 divided by 10. So you can equate directly for n to be infinity. So infinity plus 1 is infinity divided by 10, which is infinity. And remember, we have said that if limit n approaches infinity, an plus 1 divided by an is L is infinity, automatically your series diverges. So our series diverges. E raised to the power minus n, e raised to the minus 1 multiplied by n plus 1 cubed. But you can expand n plus 1 cubed using binomial expression. So it will be n cubed plus 3n squared plus 3n plus 1 divided by a minus n cubed. But remember this property, a raised to the power minus 1 is equal to a over 1. So we use it here. E raised to the power negative 1 is simply equal to 1 over e raised to the power n. So your limit will be limit as n approaches infinity. Now this one will be e raised to the power n on upper side multiplied by n cubed plus 3n squared plus 3n plus 1 divided by e raised to the power n, e raised to the power 1 n cubed. That is e, normally e. So e raised to the power n and e raised to the power n cancel. And so you can factor out 1 over e, limit n approaches infinity, n cubed plus 3n squared plus 3n plus 1 divided by n cubed. So this is equal to 1 over e, limit, you separate, n cubed divided by n cubed plus limit n approaches infinity, 3n squared divided by n cubed plus limit n approaches infinity, 3n divided by n cubed plus limit n approaches infinity, 1 over n cubed. Are we together? So this is 1, this is 1 over 3 over n. When you put n to be infinity, this is 0, this is 0, this is 0. So you remain with 1 over e. 1 over e, which is approximately equal to 0.36. And this is less than 1. So the series converges by ratio test. Converges by ratio test. Converges by. Example 3. The series is given as summation as n move from 1 up to infinity, n factorial divided by 2, n factorial. Determine whether this series converges or diverges using a ratio test. So your an is n factorial, 2n factorial. Your an plus 1 will be n plus 1 factorial, 2n plus 1 factorial. So an plus 1 divided by an is equals to a ratio test. Is equals to n plus 1 factorial by this multiplied by 2n factorial divided by n factorial this over 2n plus 2 factorial. 2n plus 2 factorial. Limit as n approaches infinity, n plus 1 factorial is n plus 1 n factorial 2n factorial. Are we together? N factorial. 2n plus 2 factorial is 2n plus 2, 2n plus 1, 2n factorial. So n factorial cancel. N factorial cancel. 2n factorial, 2n factorial. Your limit simplifies to limit as n approaches infinity, n plus 1 divided by 2n plus 2, 2n plus 1, 2n plus 2, 2n plus 1, which is equal to limit as n approaches infinity, n plus 1, you expand the denominator part, 4n squared plus 4n plus 2. Now you can solve. Equate n to be infinity. You have infinity over infinity. This is in non-determinate form. So you use L'Hospital's rule to simplify, to make it determinate. Limit n, you differentiate the numerator and denominator part separately. 1 divided by 8n plus 4. 8n plus 4, which is equals to 1 over infinity. 1 over infinity is 0. At 0 is less than 1. So the series converges by ratio tests. The series converges by ratio.